So Nina asked me to come here and talk to you about design. She mentions instructional design, and of course that's the curriculum. And I don't know anything about that, but I know a little bit about design, and I'll just give you my experience with it, because that's what this is all about. It's really about me today. So Nina mentions thinking outside the box, and I'd like to expand that a little bit to thinking outside the universe, because I don't think we should stop with the box. So what is design? Well, this is, again, me. This is my definition of it. It solves problems. It might create something new when we don't even have a problem. It really ought to be a process that makes the world a better place. And I want to focus on the process of design. So if we think about the design, our process, how do we start it? I mean, processes start at some point. And as I think about kind of the out-of-the-box thinking, a person comes to mind. In 1968, Robert Kennedy was running for president. I was in high school. And there was a lot of turmoil that year. That was a tough year. There were race riots going on, so there was a lot of concern about civil rights. Bobby Kennedy, coming from a rather wealthy background, decided to push that aside, and he wanted to see what was going on in the nation. And so he gave a bunch of talks. Of course, he's running for president. And one of the things he said that really got my attention was he said, "Some men see things as they are and say why." And here he is in a place that's well outside of his home, his growing up experience. And then he said, "I dream things that never were and say why not." And that still stimulates a little emotion in me, because he was assassinated just a little while after that. If we consider the design process, let's consider a couple of things, and certainly how to start is what Robert Kennedy did say in the beginning. Seeing things as they are, but not to just ask the question why. Let's see things as they are, and then let's consider what we ought to do with that. And that becomes the why that we do design. And it's to make things better. So if we consider now maybe the full process that I've come up with anyway, we start by seeing things as they are, and we're going to measure, we're going to take pictures, we're going to verify what we're seeing, we're going to do those kind of things. Just capture what's going on. Then we're going to dream of the possibilities, and that's where Robert Kennedy took the next thing. Imagining, dreaming of things that are not now. And so we're going to do that, and we're going to say, okay, how can things be better? What might that look like? And maybe we'll establish goals and say, we'd like to be here, we're only here. And then we're going to start to develop solutions, and we're going to draw things up, we're going to model things, we're going to do some calculating, we're going to talk to other people and collaborate. And then ultimately, of course, we'll have some solutions, we're going to test them, we'll measure, we'll verify. We may have to go back to developing. And you're going to see this in one of the examples I'm going to give you where I came up with something, modeled it, tested it, didn't work, I had to go back. That's okay. It's part of the process. Who does this stuff? Who designs? Well, okay, scientists, engineers. I mean, I'm an engineer, okay? So I immediately think of people that are in my field. Yeah, we're designing things all the time, okay? But then, I don't know, actually, it's a whole lot of different people. Let's answer this question later. So I'm going to go through this process of seeing, imagining, developing, and testing with a number of examples. So the first one I'm going to give you is, talk about out-of-the-box thinking, is my grandson. His name is Emilio. He is 6 months old. And he's designing, I'm going to propose that he's designing something right now. And we can watch him a little bit. He's trying to get around. And he's struggling with that. At 6 months, 5 months, he's about 5 months in this picture. So I'm going to say that he's seeing. You look at him, he's seeing things around him. He'd like to be there, he can't get there yet. So here he is again. Now he wants to get something. Let's watch him. gets up on his knees, and he's a little unstable, and he'd like to go there, but, okay, how about if we go here instead? I can get that. Let's try the next one. So he's still seeing. Now maybe we can say he's imagining. Now let's watch him here at this point. So he's up, and I want to get that ball. I'm gonna get it. Oh, no, okay. He's reaching. Can he really propel himself a little bit? He pulls himself a little bit with his hands. Okay. Now, let's see some progress, okay? I would say he's in developing now. Let's see what this looks like. Look at that. He's pulling at the carpet. His hands do a pretty good job. He can pull himself. His feet, though, they're more like flippers, you know. He's just, you got the thing. Now, you got to watch here for a second, because something happens here. And he's not quite at his goal yet, though he may think he is. So that was his mom just saying, you got it. Now watch him. Of course, he's going to play with it a little bit.
Uh-oh. Now you got to go over there and get it.
Yeah, you got to go over here and get it. That's another daughter, Bethany. So let's see what he does. He's looking. He kind of pumps a little bit. Now, let's go. I'm getting there. I got it. Okay. So he's making a little progress. So would we say that he's there yet? He's testing. He's still developing. He's not quite there yet. But you can see it's a process. He's learning something. He's trying things out. He's designing. So here's me when I'm about 12 or 13 years old, and I don't know where, I can't read the C because I don't remember where this idea came from. But I remember thinking, hey, you know, I'd like a car that flies. And I'm about 12 or 13 years old, and I draw this thing up. You know, I love drawing from when I can remember. And I would draw things up. I'd draw things I'd see outside houses and whatnot, cars. After a while, I kind of like cars, all right? I like cars. I think Nina said you have a picture. The picture you showed everybody has me and the Shelby. Anybody notice that? I have a Shelby. It's cool. All right, anyway, so that kind of led me into, okay, let me tell you about this Shelby, because I wanted a Shelby from 1967. The first time a GT500 came out, I wanted that car. It only cost about $5,000, but back then that was a lot of money, and I was a kid. I was in high school. There was no way. It took me, what, 40-some years, about 40 years before I finally bought one. And of course, the one I bought is a whole lot cooler than that one that was in 1967. But anyway, so I had an interest in cars, but I wanted cars to do more than cars did, okay? I'm kind of thinking outside the box. And so I came up with this idea of flying. If you can see what this thing is here, there's propellers down here that kind of go in opposite directions. I figured we need to keep this thing from spinning. And the people are sitting up here. These are air intakes here, so they'd be along the side here, so the air kind of comes in under where the people are into this and out the bottom. There's an engine in here to run it. It's an internal combustion engine. I'm showing a 2.4-barrel carburetor on the thing. It's an 8-cylinder engine. I got 8 pipes coming out the back, and I figured that might add some thrust. And I remember I never drove a car. I'm a kid. I'm looking for something that's going to get me going forward and something that's going to keep me above the ground. And so I think I got the bases covered. I go to talk to my dad about it, and I say, Dad, what do you think? I got this idea for a flying car. He looks at it. He's an engineer too, buddy. He looks at it. He says, why didn't you use a gas turbine engine? And I look at him and I said, Dad, I don't know how a turbine engine runs. I know how this thing runs. So he explained to me how it worked and all that, and I began thinking, all right, this is kind of a crappy idea because I don't have the thrust really. He used to tell me about that. You need more of those exhaust pipes to get you going. So, okay, but a gas turbine engine might work. So I'm starting to think now about gas turbine engines, but I didn't take this idea anything past what you see there. But I'm interested in cars, so I came up with this one a few years later, and now I didn't even show the gas turbine. I started putting gas turbines in everything because I thought they were really cool at the time. This is now the mid-'60s, okay, mid-1960s. And so one thing I observed is when we're driving down the road, and we didn't have air conditioning in the cars back then, so the windows are open in the summertime, and I like sticking my head out and my hands out and doing this, and the air currents and everything. One thing I'm recognizing is that there's a lot of wind resistance against a car at speed. And I'm thinking cars should be designed to be able to have minimum drag against that wind. Now, I'm still a kid, never drove a car yet. But I'm thinking, hey, how can I do this? So I come up with this really swept back windshield, and I came up with this idea that the tires in the front seem to be an impediment because they're like this. And I want them big so they can go over potholes. So I'm thinking if I do this, I can lower that whole profile, huh? Well, so that's the basis for my design here. There's the front wheels. And I come up and I showed, this time an engineer, a friend of mine who lived next door, his dad was an engineer, and I happened to show him this idea. I said, hey, what do you think of this as a car? He looked at it, and he didn't comment on this that I recall. He commented on the windshield. He said, hey, that windshield is almost horizontal. I don't think I'll even be able to see out of it. And I thought, okay, let's go back to the drawing board and find something else to do. So, okay, so fast forward a bunch of years. Now I'm in the workplace and I'm between jobs. This is at a time when computers are just starting to show up on people's desks. And I'm thinking, okay, so you put the keyboard like this and the screen is like this, and in all cases, keep just going on a regular desk. I got this little screen, and because they were small screens back then. And I'm thinking, you know, this seems kind of cumbersome because I don't even know how to type. And so I got to be doing this, and I got to be looking at the screen, I got to be doing this, and I thought, what would be a better design? I'm thinking of a better way to do this, and I thought, you know, it would be kind of cool if I use one of those ergonomic chairs from the 70s that have the seat like this and the knee thing. You remember those chairs and the place to put your feet? So I thought, let's use a chair like that, but tilt me even further forward. And then I came up with this headrest right here. I can just rest my head on it. And then this thing right here comes up for resting my chest on it. And I can say, I can just collapse onto this thing and do my work. Now, if I do this for a few years, I'll probably turn into a blob, but I wasn't thinking about that at the time. I was thinking, how could I really be comfortable and just be able to look down and see, there's the screen, there's the keyboard. And I can just kind of do this while I'm watching things, and I don't have to exercise any force whatsoever. So that was a crazy design. So what did I do? I imagined, I imagined, and then I drew it up a little bit more in 3D, and I thought, hey, what a cool thing, except that then I got a job again. And so I moved on and didn't look at it again. So, I mean, there's a lot of crazy ideas that I've come up with, and I take them just so far that I think, all right, maybe I'll come back to it someday. But I never came back to that one. So now here's when I'm in the workplace, all right? Finally, we're getting serious. Now I'm in the workplace, and my boss comes to me and says, hey, we got a client, automotive client. He says they want to, they're putting in this laboratory, and they want to be able to maintain, first of all, they have a lot of hoods, so it's 100% fresh air all the time. And they want it to be able to run summer and winter. We got to have temperature control. We have to have humidity control. And we want to minimize energy demand on this thing. Can you come up with something? And I thought, all right, so let me see what I can do. So the first thing, of course, I'm doing is articulating the problem, as you see here. And then the next thing I'm trying to do is imagine how this thing is going to work. Where am I wasting energy in this thing? And that I could capture it and use it somewhere else. What's using energy but has a discharge that is air of a characteristic that I can use somewhere else? So that's what I began thinking of. And so I came up with this little diagram, which is complicated. Now you guys, I don't think anybody here is an engineer, so this is kind of complicated to look at. But essentially it's bringing in fresh air over here, and it has to heat it, it has to cool it, because in the wintertime it's got to heat it. And in the summertime, or actually any time, it's got to be able to cool it and bring it to the right temperature conditions. And so that's what this cooling coil does over here. So the cooling coil finally brings it to the last conditions, and then I have to reheat it again over here in order to get it to a relative humidity that's not saturated, but like about 50%. And the way you do that in the automotive industry is you first bring the air to saturation when it's cold here, and then you reheat it to bring it to the relative humidity and temperature that you want. It's a balancing act. Anyway, so what I came up with was something that's used all the time and had been used since the oil embargo days of the 1970s, was a heat wheel over here to exchange the heat from the exhaust, which is air that's in pretty good shape, to this air that's coming in, okay? So I can, if I'm if I'm bringing in 0-degree air in the wintertime and I'm exhausting 70-degree air, I can pick up a lot of heat from that. But that's commonly done. The innovation here was what I'm doing back here. Nobody had done this when I thought of putting in another heat exchanger that would exchange the air that's coming in here that's warm from the preheater, and then cooling it, and then taking that cool air, and where I have to reheat it again, first thing I do is I exchanged heat with this 2 air streams here. So this cool air can then be brought over here in terms of a lower temperature on this heat exchanger and pre-cool this air. This thing right here, this thing wound up saving 40% of my energy all by itself. This was something that hadn't been done. And I showed that to my boss and gave me the problem. I said, hey, wait, this looks like a pretty cool idea. Well, calculate it out. Okay, so I go to the calculation now, and I go pull out all my psychometric charts. This is just one of the diagrams that I had to use in order to see that, hey, this thing's really going to work. And it did. And then the next thing I did was I said, all right, so what does the air handler really look like that's going to sit on the roof of this thing? And so that's what the thing looks like, with all the various chambers and components and everything. And then my boss got a request from a trade journal saying, hey, we're looking for some innovative solutions here on energy. What do you got? So my boss came to me and said, write an article. So I did. So here it is. And this was in Heating, Piping, Air Conditioning magazine back in the day. This is in the 80s, long time ago. Well, so I wrote this article, and then it wound up being something like, it was about a 10-page article that included all the various diagrams that I did and all the explanation and everything. And it was a cool thing to do. Probably what I should have done was patent the stupid thing, but I didn't think of that. I thought, this is cool, and this is typically me, okay? I think something's cool, and so I just want to tell the world about it, so I did. But I did get some comments after the article got published in terms of a couple of people called me up, and somebody called me up from a university in Florida. I remember saying, hey, that was really an innovative idea, we like that, we're going to try that out on something. And I just remember thinking, hey, that's pretty cool. So I figured it was a success. Now we forward to another company that I'm working for. This is a cereal company, and they came to me and said, you know, in our production lines, particularly where we're coating the cereals with sugar, we have a problem in that there's sugar dust all over the place. And we've tried to put in some systems to capture that dust, but it's just not working. Can you come up with something? And so here, let me explain this thing. So we got this belt conveyor that has cereal on it, all right? This is the head pulley of the belt conveyor. And it's going in, dropping this stuff down into a chute that might be going to a feeder or a measuring device, or maybe a conveyor that's now going this way instead of this way. And anyway, so here it is, and they said, we've tried some things in terms of pulling the dust off of it. And one of the things I observed was a scraper sitting down here, and then this is a hopper actually going to a fines collection, a fine particulate collection system. And so I went out to the plant, and I spent a few days looking at different things, and I'm in the seeing phase, all right? So I'm looking at a few things, and I'm seeing, in one case, I'm seeing this plastic scraper. And I'm seeing a couple of interesting things about it. First of all, these belts have a metal splice around them, and that metal splice hits this thing, and it's like, you know, it's like constantly hitting this plastic thing, wearing it out. And the thing wasn't even touching part of the conveyor. But the other thing I observed was there was all this dust on the back side of the thing, not on the front side. I would not have imagined that if I didn't see it. And I saw there was another type of belt cleaner they had. It was actually a rotating thing. And it would just go round and round and round. This motor's running, it's going brrr, making all this noise. And dust is flying around every which way because it's not landing in here. And I thought, okay, what is going on? Why is the dust going every which way? I knew why it was with that rotating thing. But on this one here, why was it going everywhere? So the only thing I can think of is static electricity. These particles get statically charged, and they're not going to go where you want them to go. And they're going to stick to stuff that you don't want them to stick to. And so that's why I'm seeing them, I think, on the back side here. So after observing those kind of things, I'm thinking, all right, so what might a solution be? So I'm imagining now the solution. And the solution is that these statically charged particles need something to capture them that's not there today. I do need belt scraping, because I gotta disturb those particles, and that's the only thing I can think of that's really gonna do that. But what that scraper has gotta be a very different scraper than what I'd seen so far. So the next thing I'm imagining is, gravity has no effect on statically charged tiny, tiny particles. They're gonna float wherever they want, gravity doesn't do anything, but air will. So I'm thinking, I gotta do something with the movement of air. I gotta force it. And then of course the last thing is, so what is the shape of this thing gonna be that's gonna force some air, it's gonna scrape the conveyor, and it's gonna last for a while. So let's see what I came up with. So, okay, here's the first drawing of something that I had. This is a side view of something that I was going to actually try to spin the air. Oh, I gotta tell you one other thing. So I thought, how much air do I think I need on this thing? And so at another time, I'm driving the car. I drive now, and I'm on the highway, and I'm watching the windshield wipers, you know, and they're working and stuff. And it occurred to me to ask the question, how fast do I need to go to clean this water off the windshield without using the windshield wiper? Because that may be the speed I need to go to clean these belts. This is back when the speed limits, remember, national speed limit was 55. So I start pushing on it. And I'm on the highway, okay, so it's all right. And I'm doing 60 and 65, it's not working. And I'm doing 70, and I'm hoping there's no red lights anywhere. I get it up to 75, and now the water's beating up. And it's just coming right off the windshield as fast as it's landing on it. And I'm thinking, that's the speed. I need a hurricane going on inside my cleaner. Whatever that's going to look like. So, thus this design. Now this design here was one where I was picking up air at the end. I'll show you another view of it here in a second. And I'm spinning it around this thing. So the belt's coming back like this. It's coming over this like this. And then I'm spinning the air. I'm trying to spin the air the other way with this shape. And then I want to pull it out here. And I'm going to hook this up to a fan and into a dust collection system. So that was my first attempt. Here's what the thing looked like. And I had a whole bunch of drawings drawing this thing up. I went to a fabricator and I said, hey, fabricate this thing. Out of what? And I said, well, it's got to be able to handle that belt splice, so we got to make it out of steel. But they're also going to wash this thing down, so we got to make it out of stainless steel. Let's make it out of 304 stainless steel. And so, okay, we'll do that. And this thing wasn't cheap. But he built the thing for me. We put it on one of the conveyors. So you can see, here's what happens. The air actually comes in like here, like at this end here through this, and then it spins around like this because I got all these flutes in here that are moving the air. Finally, it comes out the back end, and then I have a fan right here, and I stick it into a dust collection system. So I had to run a bunch of calculations to see how much air pressure drop I have. So I did all that, and we set the thing up, but it didn't work. The air velocities were not what I expected them to be. I didn't have the concentration of air where I needed it. The thing wound up filling up with dust, so I thought, all right, I got to do something simpler than that. So I came up with this. Now this one, I was able to take a picture of it, because it's a long time ago, but I have a picture of it. This particular one right here, I figured I'd have to simplify. Now the air just goes in through the end at 75 miles an hour. The belt comes across it like this, and it scrapes onto, lands onto these three surfaces. So I figured it lands on the first surface, stuff's going to go off the backside, the dust, great. I got air, I'm going to pull it. If it doesn't all go off on the backside, it goes off on this side, I got a second chance to pull it. And I'm going to pull it in here to the center. I'll show you another view of the center. By the time it gets to the back right here, I have the belt gliding on that only for the purpose of not letting air get in here. I want to get all the air to come in this way so I get that cross velocity. So I do that, and then I have this front pan on here in case there's any big stuff that comes off. It'll bump off of this and then land, you know, particles of Fruit Loops or whatever, and they'll land on that and go down into the conveyor. So let's see, here's another view of the thing, and you can see this is where, again, all the, any actual cereal products that come across and still are attached to the belt, they'll get knocked off onto that and then go down the regular chute. The thing I wanted to show you here was I had to offset these air pickups so they don't have a dead space in the middle of the cleaner. The air is going to come in like this, and when it gets to that spot, it's going to go like that. I got to have a dead space in here, so I figured I'd offset the two. I got one here, and then I got one over here, so I have that center place covered for the most part. Anyway, then I finally tested it. We had one, as you can see, we had the thing built, had it installed on one of the conveyors. It was sitting there for a year and a half, and the operators liked it. It worked. It didn't get clogged up with dust. It did the job. And then after about a year and a half, we had another request for some new lines at another facility, and we wound up putting in, I don't know, like 50 of these in another facility. And it worked. It did the job. Anyway, hey, let me show you the next thing. So so here's another thing that happened at the cereal company. I moved from engineering into an innovation group. And in the innovation group, our job was to come up with new things, new processing platforms, new product platforms, maybe new packaging. And so one day, and I'm in this group trying to think of, okay, what can we come up with? We're talking to different people, collaborating with all kinds of people. And one thing I used to do was, I used to like to have sunflower seeds in the car that I would eat. And I came up with this container right here. This just, I'm sure you've seen these. It's for like Kool-Aid, the Kool-Aid dust. And anyway, I found this to be a pretty good cup for this because when you tilt it like that, you see how you've got this shape right here. You can have some depth of sunflower seeds in this thing. You stick your tongue in there, and you always get a nice chunk of sunflower seeds. So I like that. Not like a regular container. It's like a jar or something where you really got to tilt it and then all of a sudden it comes at you. So this worked out pretty well. So I'm sitting there going into work one day, driving, and I'm eating sunflower seeds, and I'm imagining this thing and thinking, what else could I put in here? I'm going to get sick of sunflower seeds after a while. What if I put Rice Krispies or Fruit Loops? Fruit Loops are really kind of sweet. Rice Krispies don't have that much taste to them. I really got to have milk in there. How am I going to have milk with this? So I just started imagining that if I had two chambers in here, and I could take some of the cereal like this, and then if I turned it, and had a straw out the back to another chamber, I could be doing this. And so I thought, hey, got into work and I drew that picture you see there. I thought, first of all, I got to enhance it. I can't just have two chambers. So I thought of, so here's the concept. Concept is, here's where the milk is. Wasn't really sure how I was going to get it in there, so I just figured, I probably got to get it in from the bottom. Some kind of a cork or something, all right. Didn't know yet. Well, I'm going to have this thing tilted with the idea that as I'm starting to make it go this way, well, that tilt thing that's now like this, all right, here's the jar and here's the thing. By the time I get it up to 45 degrees, I got a bottom that's already horizontal. So I can just go like this and get it all out of there without tilting the whole thing. So that's the idea of that shape. The straw coming out the back, the other thing is, being it's in the back, when I'm tilting like this, the straw's back here somewhere, so I don't think milk is going to come and hit me in the face. And then all I got to do is I can put I show a screw top on this with the idea that I can close it up when I'm not using it. So then I went home that afternoon after drawing this thing up, and I figured, I got to make one of these. So I went to the grocery store on the way home. I thought, I got to find a container that I can like cut it all up and whatnot and make these two chambers. So I went to the juice aisle and I find orange juice. We run out of time? No? Okay, good.
20 minutes.
Yeah, you're good.
How much?
You got 20 minutes.
Oh, good. All right, so I go to the juice, and I'm looking at all these juice things, and I come up with these guys right here. What is it? Sunny Delight, Florida Citrus. Okay, so that is actually, oh gosh, I can't even get it apart. It's been in there so long. This thing is like 25 years old. Well, here it is. It does come apart. So what I did was I put milk in the bottom, and then I close it up right here. I got the straw out the back. See, the straw comes through the hole. There it is. So the straw out the back comes through the hole, goes down into this. So now I put this into here, and I threw some cereal in it, and I bent this thing all up, as you can probably see right here. It's still joined here, but I cut it so I could put the whole thing on a tilt, and then I would do this. So I brought it into work the next day. And I made this thing just like in my bedroom at night. Cut it all up with a knife. And then I brought it into work and I showed my boss. I said, hey, I got this idea. What do you think? And so he said, wow. He said, let's go down and show the vice president of research. See what she says. I went down and showed her. And she said, whoa, we got to take this downtown. and show senior management. So she makes some phone calls. She says she's going to take me down there. And I'm thinking, wow, cool, all right, this is exposure. And so she says, I got you an appointment with Carlos Gutierrez. Anybody know that name? Carlos Gutierrez was at the time president of Kellogg. He later became the Secretary of Commerce under George W. Bush. All right, so this is the guy. And then Donna says to me, she's the Vice President of Research. She calls me up later, about a half hour before the meeting. She says, something came up, I can't go, you just go. So, okay. I go trotting down to the headquarters with this. But, hey, it was okay. I go into his office, and he's busy doing something, secretary. You know, we're talking about like the 8th floor or something on this headquarters building in the middle of Battle Creek, Michigan. That's where Kellogg's headquarters are. And so I sit down, and then he comes out and says, come in. So I go into his office. He immediately knows who I am. He's a really nice guy. I like him. And he says, show me what you got. So I show him, I go ahead and do the whole thing. I said, hey, look, I got this. I got some cereal in here. And then I go ahead and do this, take some, and I turn around, and I take a little sip, and he goes, whoa. His comment was, that's got some entertainment value. He says, I want you to pursue this. Go make it happen. I said, great, I will. Well, so the politics of it, the designers oftentimes don't get into, is that same week, the packaging department was putting together some new packages. They were trying to get rid of the liner in the cereal box, so there was plastic boxes. Made all fancy, hired some designer to put this thing together for them, paid $300,000 to put a few boxes together. And they had gone to show Carlos Gutierrez their thing, and he said, I don't see it, guys. I see a lot of money being spent on this. Get this stuff out of my office. That was it. That put me in the crosshairs. Because when they heard about later that Carlos liked my little crazy idea, he didn't like theirs, it was a problem for me later. But anyway, so what the next thing that happened about that was they said, all right, let's hire another one of these designers, industrial designers. Wait, I went the wrong way. And so we started coming up with these kind of little storyboards, okay? And it just so happened that there was a focus session coming up to test consumers' response to different things. And so it was going to happen in Seattle, Washington. So there were a bunch of people going. I said, look, I'm going to get a ticket. I'm going to go with you. Okay, no problem. So I went there, and I have my little boards up and stuff. And we're sitting in a conference room that's like only about, it's like maybe a third of the size of this room. And there's all these people sitting around, potential customers, and a handful of us from the company. And others show them different things. They got products to taste and whatnot, and they're sending this thing around. And so towards the end of the thing, I got my thing. So I put my thing up, and I said, so I got this idea, and I described it to them a little bit, and I said, so what do you think? And the comments I got from people were really interesting. So there were some young people in there that thought, that looks pretty cool. I think I could take that to school with me. There were some older people that said, I really don't know. I'm going to have to think about that. I had one guy say, I wouldn't touch that with a 10-foot pole. So it definitely stimulated. Nobody else got those kind of comments that were showing their stuff, just me. But it was okay. So from there, I went out and, let's see, what else did I do? Oh, no, that's the next thing. So, so what wound up happening was I got a patent on this thing. And because I went ahead and prepared all that, went to see a patent lawyer, and we got a patent on it. And at the same time, we were looking to see how Kellogg might be able to use this. And so Kellogg was actually a little squeamish about that particular design because it looked like it was going to, again, be costly. Maybe this wouldn't be a one-off like you buy a box of cereal and you throw it away. It might be something that somebody else makes. But Kellogg took a shot at it. And they came up with this. And this product is a little different. It was pretty inexpensive to make. And it's brittle because it's old. They only did it for a little while. Forget, I'm not opening it. But it is 2 containers. Oh, what did I say? So it is 2 containers in one. So they put the milk in this, and the cereal goes in this. And instead of having a straw, though, they had this little thing here, this little hole for your tongue. And so when you have to have milk in there, you cover it up like this. And actually, you'd buy it like this. This would come in the refrigerated section. So the idea is that you would be pouring cereal in your mouth while you're, with your tongue, you're controlling the amount of milk that came into it. But it didn't work real well. It was a different idea than mine. And so it didn't sell real well. So that was kind of the end of that. But another company came along after Kellogg, and I think after the patent expired. I mean, this was more than 20 years ago that they did this stuff. So you can buy these now. Okay, it's a kind of a knockoff of the same thing. So you've got this container right here that you put the liquid in. You got, again, the straw. Whoops. The straw that comes through this other section right here. And just goes in there like this. And this goes in here, but I still got the instruction. And so there you go. And you can have cereal in here. And now it works. The only thing is, this hinge thing, I don't like it. Because I'm not sure how I'm actually going to pour this and not get milk all over me. So I don't think this is the best design. I still think my design was better. Anyway, that's what happened with that. So I think enough of the show and tell for that particular product. But anyway, we're able to get a patent. We're able to kind of change some minds, some thinking, and try some things in the marketplace. And it was a cool thing to do. Anyway, so I fast forward, we'll leave that company, and here's the last thing I'm going to show you. It's just something that is more, as you might find in planning. Planning actually is not that much different than design. And so in my current role now, I'm helping different organizations, utilities, university campuses, and even industrial parks on energy master planning. And there's a lot going on in that business right now because the big utility companies with their big coal plants, well, you probably are very much aware that those are becoming a vanishing breed. Coal plants are being shut down all over the country, and people are looking for alternatives. A lot of those alternatives are renewable energy, particularly wind farms and solar PV. We're also seeing, of course, more natural gas being used in combined cycle plants. But a lot of that comes down to, so what's the most efficient thing you can do? And a lot of people are interested in, how do I minimize my greenhouse gas emissions? And so when they start asking those kind of questions, and even sometimes setting goals without thinking about how they're going to get there, and a lot of universities are doing this right now. I don't know what BYU's doing. I haven't checked you guys out. But where I come from in Michigan, I know about those goals that are there in the Midwest. And so one of the things that I've done is I've developed this process, did it actually with Michigan State University. And in this particular process, we start off with, where do you want to be? The goals, number one. And what kind of things do you want to accomplish? And so things like, oh, we got to eliminate greenhouse gas, we got to reduce it 20% by the year 2030, we got to reduce it 50% by 2035, and things like that you see that these guys have. And then number two is the status. It's like, where are you today? What are you doing today? Well, we're burning natural gas, we're doing this and that, we have to do something about that. Okay, so what are the gaps? Number three is like, so what's between where you are today and where you want to be in the future? So this is kind of design, isn't it? And so we define what that is. And then the next one is timing. When do you need those gaps filled? And so we come up with, now we can put together a schedule of events. This year, 2020, we got to do this. 2023, we got to do this, and so forth. And then after that, you look at, okay, so now we know what has to be done, but how are you going to do it? That's the choices. That's the technology you're going to use. Are you going to wind up using some renewable energy to get there? Or are you going to do something in terms of combined heat and power or cogeneration? Because you may need heat. Or are you going to come up with something else like Stanford University has? They got a really unique system, but I'm not going to tell you about it because you're probably not a bunch of engineers. It's complicated, but it's cool. But anyway, so universities are doing some cool stuff. And then, of course, ultimately, it's like, what's the right choice, or choices, depending on your time frame. You might have to do something in 2028 and something else in 2032. You know, so you look at all those things, and depending on where you're at with the technology and where you're at with with just what's available in the marketplace and what the goals are. You come up with something, and then you do a financial analysis, and that's what gets you to some selection of choices. And so that's the kind of thing that, that I'm doing today. Anyway, so if we go back to the basics, what is it about design? It's first about seeing, and that means open your eyes. It's about imagining, and that's opening up your mind. Take it outside the box. It's about developing, and that means focusing your mind. It means thinking up solutions and beginning to draw them up, define them. And then it's testing, and that's opening your eyes again. And in the case of testing, you're going to find that maybe some of what you're trying to develop isn't working. You got to go back. You might have to redevelop. But can everybody do this? Let me close with a couple more things. Remember little Emilio? He's doing this as he's figuring out how to get around. His mobility is his design. Think about Bobby Kennedy. His thing was to design a nation. So whether we're talking about designing how we're going to get around, or whether we're talking about designing a nation, we're probably somewhere in between that, but we are all designing. Everyone designs. Design does create a vulnerability. Brene Brown said that vulnerability is the birthplace of creativity and innovation. If you don't know Brene Brown, she is she's got two talks on TED Talks. Go to TED Talks, look her up. Because if you're talking about design, if you're talking about anything that has to do with creativity or innovation, you've got to hear her talks. They're great. Yes, vulnerability is going to be part of it. Embrace it. Accept it. Be courageous. Share what you've got with others. Let them tell you. Let them tell you, hey, why didn't you try out a gas turbine engine instead of an internal combustion engine? It's okay. Windshield is too horizontal. You won't be able to see out. It's okay. Take the comments. Don't be discouraged. Keep going. Persist. So under persist, my dad said to me one time, it was after he told me about the internal combustion engine should be replaced with a turbine engine, but he said to me, he said, you know, you have ideas. He said, when you have an idea, you got to be ready to defend it, to develop it, to champion it. And if you don't, you'd be better off not even having it in the first place. My dad was a tough guy. And then I would like you to, so these are my final comments to you, things I want you to take away. I'd like you to encourage other people to have ideas. And if they come to you, be a kind of person where they're going to come to you and say, hey, what do you think of this? Your kids are going to do that. But other people should do that too. I do have an open door policy in my office where people come to me and they ask me, hey, what do you think of this? And I think that's great. So I'm still working, in fact. And so encourage people to do this, to come to you with comments. And then when you come with ideas, and when you talk to them about it, make sure they understand you're not there to be critical. You're there to help them. And there's a fine line of the kind of language you use, and the body language, and the verbal that you use in order to say, hey, I want to help you. Here are my comments, as opposed to just being critical. And then ultimately, being creative really makes for a more rewarding life. I have to admit, I like my stories, and I have a lot more than just these that I just told, share with you. But it's cool to come up with something new. I gotta tell you, when the light bulb goes out, bink, it's like, wow, I love life. Let's go see if we can make this happen.